Today class I'm going to teach you about projectile motion. The motion of a ball is an example of projectile motion. The ball is a projectile and the path it travels is its trajectory. In a laboratory experiment, a special device was used to project a ball in a horizontal direction, at the same time releasing a second ball to fall freely from the same height. It was found that the balls reached the floor at the same time. This was based on the fact that a single sound was heard as they struck the floor. This result suggests that the vertical motion of the projected ball is not affected by its horizontal velocity. Therefore, projectile motion is a combination of vertical and horizontal motions that are completely independent with each other. So today I'm going to teach you about projectile motions at arbitrary angles. It includes the angles. So if you heard me earlier, the x and y component are completely independent with each other. So this includes angles. So we're going to use the functions sine and cosine. So we do know that a sine is the opposite over the hypotenuse, and we do know that the cosine is adjacent over the hypotenuse. So sine is used to compute the maximum height, and cosine is used to compute the distance traveled horizontally. So yeah, we're going to give you an example problem. A golf was hit and projectile at an angle of 60. So this at 60 angle. So the angle theta is 60 and the initial velocity of the ball is 50. So we're going to compute the maximum height of the object and horizontal distance and the time it traveled. Time. Dx and the time. So the first formula would be VI sine times the angle theta. So VI times the 50. VI times VI means 50 and sine and the angle theta. VI y. So if you compute it, you will need a calculator. So 50 times sine 60 equals 40.45. 40.45. And we're going to get the initial velocity, which describes the x component. VI x equals 50 cosine 60. So cosine 60 equals times 50 equals 20. VIX equals 29.39. Now we're going to compute for the object's time. So we're going to compute the time up, which means the time which the projectile covered onto the maximum height. So T up equals VIY, VIY over the gravity, which is 9.8. So yeah, VIY equals 50 sine 60. So 40.45. So if you compute it in the calculator, it's 40.45 divided by 9.8. It's 4.12. 4.12. So it's only the time up. So we're going to multiply it by 2. So we're going to compute the time which the object covered, its maximum height and the ground. So it will be 8.24 seconds. So yeah, Now we computed the time. We can compute now the horizontal motion of the ball. For dx, formula is vix multiplied by time. So dx equals vix multiplied by time. So dx equals dx 29.39 multiplied by 8.24. So it will be 242.17. 242.17 meters. So yeah, today and we're gonna compute for the maximum height of the object. dy equals final velocity vf squared plus initial velocity squared over 2g. Reminders, it is the y component, so initial velocity which for the y component and the final velocity which for the y component. So vf equals 0 because the final velocity of an object is the initial velocity, it is equal. So the initial velocity of it is 40.45 squared over 2g. So we're gonna compute it, we're gonna punch it in the calculator. It will be so it will be 83.48 m. So this is the object's maximum height. 83.48. So dy equals 8.48. Ta-da! So we computed it all. So yeah, so this means the final, and I hope you learned something from me. Thank you very much.